In this video, we are going to talk briefly about piecewise functions. Okay, so what is a piecewise function? So we've been talking more recently about linear functions, and we're going to kind of stick with linear piecewise functions. We're going to learn later as we learn about quadratics and absolute values and all these other things. How to make piecewise functions with other stuff in them, but we're going to stick with pretty much linear stuff. So a piecewise function is basically a function that is broken up into different pieces. Brilliant. So I think the easiest way to jump into this is by taking a look at an example. So we're going to do an example of a piecewise function. We're going to write it out with its notation, with its weird notation and all that kind of stuff. And then we're going to graph it and see what this looks like. Okay, so here's going to be our piecewise function. We're going to start with f of x. Remember that f of x is just y, right? Don't get scared. It's a function of x. The function f of x is f of x. Yeah, anyway, it's just y, right? So we're going to define a piecewise function that has two pieces in it. And the way we denote a piecewise function is we use kind of a big curly brace here, right? So we got a big curly brace, and then inside of here, we're going to define, in this case, we're going to define two pieces. We're going to define the first piece as negative 1/2 x minus 2. Excuse me. And then our second piece we're going to define as 3x plus 4. Now, we need one more thing going on here. So we've got basically two linear functions, right? We've got f of x equals negative 1/2 x minus 2, and we have f of x equals 3x plus 4. Now, what we have to do here is we have to define the interval or the range where this function is for different parts. Okay, so this first one, we're going to say that it is for x is less than or equal to negative 2, right? And then this next part we're going to say is for x is greater than negative 2. This is really common. You don't have to have this overlap bit where these numbers are the same in a piecewise function, but it's really, really common. Okay, so let's graph this guy and see what it's going to look like. So we're going to draw our axes like normal. We're going to drop our ruler on here. We'll make it pretty. Make sure you're using a straight edge when you're doing these, guys and gals. It's going to make your life way easier. It's going to make your notes better. It's going to make your homework better. It's going to make your quizzes and tests better. All that kind of stuff. Because if you're not, it's just lazy and silly. Because you can always use like a textbook or notebook or whatever else, something straight to make a straight line. You don't have to have a ruler. Rulers are cheap as well, right? And it's going to look better. Now, it's going to take a little bit longer, of course, right? But it's worth taking that time and slowing down and making something that's going to be neat and that you're going to understand later. So we've got our x-axis right here, and we've got our f of x axis right here, or our y-axis, right? Okay, so that's what's happening. So we need to go and look at our interval position and all this kind of stuff. So I'm going to kind of draw this in with a pencil to start with. Right? So what I'm gonna do is I'm gonna graph this first function and this second function kind of separately. I'm gonna use a pencil to start this out. So this graph, of course, to graph this guy, we go down to the y-intercept of negative 2, and we put a dot. And then we count a few points. We go down 1 over 2, down 1 over 2. That's plenty, right? And then I'm gonna kind of just put just kind of a dash line, because I'm going to erase most of this in a minute anyway, but I'm going to kind of do a dash line. So this, let's see, can we see that? I don't know that you can even see that very well. I'm going to go ahead and do this. This is not going to erase quite as well, but I'm going to use a darker pencil to do this a little bit darker so that you can see that on the video. Yeah, I think you can see that fairly well-ish, right? Okay, so this one is f of x equals negative 1/2 x minus 2, right? That's what this line is. Now I'm going to graph this other one. So I'm going to come up to +4 on the y-axis for my y-intercept. So 1, 2, 3, 4, right? And then I'm going to go up 1, 2, 3 over 1 and put a dot right there. We're kind of getting up, so I'm going to go backwards on both and go down 1, 2, 3, and back to the left 1, right? And then I'm going to, with my darker pencil here, I'm going to kind of give a penciled in line. Now, you don't necessarily, this is a little bit late to be saying this. You probably have already drawn all these. But if you're using this to take notes, you don't necessarily have to write this pencil part yet, because this right here is not what this piecewise function looks like. Okay, so now in order to think through what this piecewise function looks like, we need to kind of look at our intervals. So our intervals are, okay, our graph is this one when x is less than -2. So -2 is right here, right? So right here, everything this way is, that's an arrow. Everything this way, it should fit with this, and it's equal to. So right, that's going to be a solid circle. So I'm going to grab my actual color here so we can see what's happening. At -2, I didn't really mean to make these to where they basically intersect. That was kind of accidental. It's going to make this look kind of ugly. That's what I get for just making up something off the top of my head. But everywhere this way, this is what the graph should look like. So from here and over, this is what my graph should look like. I wonder if this really is where they intersect. I have to solve that system to figure that out in a minute. I kind of doubt it. I bet it is just a little bit over, but I don't know. I'd have to wait. This lesson is not about solving systems. We'll do another example that's got a little bit bigger separation and it's easier to see here, right? Okay, so for the other part, it's for everything in this positive direction from -2 this way, we follow this rule and this pattern, right? So for this one, it's not equal to, and it's going to have a open circle, right? And then it goes this way, right? So this is what this piecewise function it looks like. For one part of it, we follow one rule, and for another part of it, we're following a different rule. And so that's what it looks like. So if I was to go here, then I would go ahead and erase these pencil marks so it's easier to see what's happening. All this sort of brownish color, tannish color, that's what this piecewise function looks like. Let's do a slightly different one that's going to be a little bit easier to see. So that's our first example, which is kind of an odd example, but it's absolutely a correct one. Let's look at another example. I'm going to flip my page over here and look at a second example that may be a little bit easier to see. So let's graph this piecewise function. Let's change colors, because why not? Getting tired of that color. Let's use a nice pretty blue color. Right? So let's change the g of x just because we can. So g of x equals, and then we're going to define two pieces of this piecewise function. We're going to do x minus 2 when x is less than or equal to -1. And let's say it's going to be x plus 3 when x is greater than -1. Okay, so let's graph this dude. Let's graph him. Let's draw our axis. We're going to kind of do this one without the pencil step. We're going to kind of go straight to graphing this, but we're going to draw our axes on here. There's our g of x axis. And then right here, of course, is our x-axis. We'll label these to where, so that we know what's happening. That's x-axis. That's the g of x-axis, right, which is the y-axis. Following me so far? Yes. Okay, good. So this is what we're going to do. We need to go to our interval here. And for this first part, I'm going to do kind of a dashed line at our interval. So I'm going to do an up and down bit at our interval. I'm going to do a pencil mark again. Kind of where this is going to live, right? So far, so bueno. Yes. Okay, good. Now, on this side, so less than, we follow this rule. We made our slopes the same on this one, which is going to make it nice and easy to see what's happening. But our intercepts change, right? So this side, we're going down 2, and then it's up 1 over 1, up 1 over 1. So it's going to be like that, right? So for this first part, right here, we have a filled in circle. And then we go this direction. And it's filled in because for this interval, it's equal to, right? And then now this one, it's the same slope, right? Up 1 over 1, up 1 over 1, because if there's not a number there, it's a 1, right? And then, but in this part, our intercept changes to +3. So 1, 2, 3. And so it's going to look like that guy, right? This time we have a filled in circle, so I'm going to kind of start to the right of it a little bit. And then I'm going to kind of fill in roughly, but with a clear circle. So see, that's what we're looking at here. And this is another really, really great simple example of a piecewise function. We're not going to go too much into, we're not going to do any more examples really right now. There are some other really specific ones like the greatest integer function and the step function, which are really cool, which have kind of this sort of look where you could graph this like this, and then it just kind of keeps going. Those are some very specific piecewise functions. This one is a step function. There's some examples of that in your textbook and some of what those look like and some special notation for those, but it's going to be easier to just look at the notation there for that. That's it for piecewise functions. That's how to graph them. Again, we can do these where these are not linear, like say this was x squared plus 3 and all that kind of stuff, but we'll talk about that later when we get to those types of functions. That is it for this topic.